Ever wondered how testing is done in object-oriented analysis and design? Well, let's delve into the fascinating world of object-oriented testing, a critical facet of software development that ensures the quality, correctness, and reliability of your code. This type of testing zeroes in on the unique aspects of object-oriented concepts, such as classes, objects, encapsulation, inheritance, and polymorphism. It plays a vital role in identifying defects early, validating system behavior, and ensuring that the software meets requirements. This testing isn't just about finding bugs, it's about making sure the software behaves as it should in its intended environment. It's about creating software that's not just functional, but also reliable and efficient. It's about building something that meets and even exceeds user expectations. So buckle up and prepare to embark on a journey into the heart of object-oriented testing. By the end of this video, you will have a clearer understanding of how object-oriented testing works in OAD. Let's dive into the key concepts in object-oriented testing. Object-oriented testing is a multi-layered process. At the base level, we have unit testing. This is where we evaluate individual classes or methods to ensure they perform as expected. It's like checking the ingredients of a recipe, verifying each one is up to standard before mixing them together. We often use techniques like mocking or stubbing to isolate these ingredients from external influences. Moving up a level, we have integration testing. Here we're checking how different components or modules work together. If unit testing is about the ingredients, integration testing is about making sure they mix well to create a delicious cake. We're verifying the interactions among classes or subsystems to ensure they harmonize perfectly. Next, we have system testing. In this stage, we're testing the entire system to ensure it meets all the requirements. We're tasting the cake now, checking if it's baked well, if the flavors are balanced, and if the texture is just right. System testing includes both functional and non-functional testing, focusing on the end-to-end behavior of the system. Finally, we have acceptance testing. This is the stage where the stakeholders or the customers taste the cake. They validate whether the system meets their business needs. Acceptance testing often involves use cases or user stories, making sure the software delivers the value it's supposed to. Now let's look at the test design techniques. We've got two main types: black box testing and white box testing. Black box testing is like a magic trick. You're not concerned with how the trick is done. You're only interested in the end result. We're testing the functionality without considering the internal implementation. This technique is ideal for system and acceptance testing, where we're more concerned about what the system does rather than how it does it. On the other hand, white box testing is like being the magician. You know all the secrets, all the internal workings. It involves knowledge of internal structures, allowing tests to be designed with a detailed understanding of the code base. This technique is often used for unit testing, where intimate knowledge of the code can help uncover hidden defects. We also use techniques like boundary value analysis and equivalence partitioning to identify critical test cases based on edge cases and common scenarios. And we use mocking and stubbing, especially in unit testing, to isolate components and test individual behavior without external dependencies. Understanding these concepts is crucial to efficiently perform object-oriented testing. Now, how do we test the unique features of object-oriented systems? Well, just like a detective, we systematically examine the various aspects of the system. We start with encapsulation. This concept is all about hiding the internal workings of an object and exposing only what is necessary. When testing encapsulation, we focus on the public interfaces. We check if they are working as expected, while the internal details remain hidden and secure. It's like making sure that a locked box opens with the correct key, but stays firmly shut otherwise. Next, onto inheritance. Picture a family tree. Inheritance is like testing whether characteristics have been correctly passed down from parent to offspring. We test derived classes to ensure they've properly inherited behavior from base classes, without any unexpected side effects. It's akin to confirming that a child has their parent's eye color, but not their bad temper. Then we have polymorphism, a fancy term for a simple concept. Think of a single word with multiple meanings. When testing polymorphism, we validate that methods, much like words, behave differently in different contexts. We ensure that method overriding and overloading operates correctly, like confirming that the word bark means the sound a dog makes and the outer layer of a tree, depending on the situation. Lastly, we test associations and aggregations, which are relationships among classes. It's like testing the strength and reliability of the connections between different parts of a structure. We make sure that data handling and interaction between classes are done properly. Imagine checking that the beams in a building are securely fastened together and that they distribute weight as they should. As we test these object-oriented features, we're like investigators, ensuring that each part of the system is functioning correctly. We're checking the locks, the family tree, the meanings of words, and the connections in a structure. Each of these tests is a vital part of confirming that our object-oriented system is functioning correctly and efficiently. So, the next time you're testing an object-oriented system, remember, you're a detective, investigating each aspect of your system with precision and care. Whether you're testing encapsulation, inheritance, polymorphism, or associations and aggregations, each test is a vital clue in your investigation. And remember, the goal of testing isn't just to find errors. It's to ensure quality, correctness, and reliability. It's about making sure that your software meets requirements and delivers the best possible experience to its users. So, keep testing, keep questioning, and keep improving. Testing these features ensures that your object-oriented system functions correctly and efficiently. But how can we make our testing process more efficient? The answer lies in the power of test automation. Automating the testing process can drastically cut down on time and effort, allowing for more frequent and comprehensive testing. Automated unit testing tools such as Junit, Nunit, and PyTest provide a platform to test classes and methods with ease and precision. Once written, these unit tests can be rerun at any time, providing instant feedback on whether changes have affected existing functionality. A step further in the automation journey is continuous integration, or CI. This practice involves integrating code into a shared repository several times a day, with each integration being verified by automated builds and tests. This ensures that defects are detected and addressed promptly, significantly reducing the cost and effort of bug fixes. In addition to automation, behavior-driven development, or BDD, is gaining traction. Tools like Cucumber or SpecFlow allow stakeholders to write tests in plain language, fostering collaboration between developers and non-technical stakeholders. This ensures that everyone has a shared understanding of what the software should do and how it should behave. These automation practices are highly beneficial, but to truly ensure a robust and efficient testing process, it's essential to adhere to some best practices for object-oriented testing. Firstly, write testable code. Design your classes with testing in mind. This means promoting encapsulation and modularity, which can greatly facilitate unit testing. Secondly, test early and often. Don't wait until the end of a development cycle to start testing. Integrating testing into your development process allows you to identify and fix issues as they arise. This not only saves time, but also enhances the quality of the final product. Lastly, remember that testing is not just about finding defects. It's about validating system behavior and ensuring that the software meets requirements. So always keep an eye on the big picture, focusing on the overall behavior of the system, not just individual components. With these best practices, you can ensure that your testing process is as effective as possible. So, what have we learned about object-oriented testing in OAD today? We've delved into the heart of this testing approach and its key concepts. We started with understanding the different levels of testing: unit, integration, system, and acceptance testing. We then explored the design techniques to apply, like black box and white box testing, boundary value analysis, equivalence partitioning, and the use of mocking and stubbing. We also examined testing object-oriented features such as encapsulation, inheritance, polymorphism, and the relationships among classes. We understood how crucial these concepts are in ensuring the robustness and reliability of our software systems. We highlighted the importance of test automation, employing tools like Junit, Nunit, or PyTest for automated unit testing, and integrating continuous integration into the development process. Moreover, we emphasized the significance of writing testable code and testing early and often as best practices. Remember, efficient object-oriented testing is key to developing quality software systems. Happy testing!